Hello again, friends, and welcome to another 1230 Facebook Live here with Arizona Science Center. Now, in case you don't know, my name is Maverick, and I'm going to be your guide here through our awesome little science journey that we are about to embark on together. And this journey is going to be a little shocking. It's going to be electrifying. It's going to be pretty fun. So strap in, guys. It's going to be a good time. Now, what I want to talk about today while we are going through our science demonstration here today is electricity. And there's a couple different types of electricity, and I'm going to focus on kind of the two main ones, the ones that a lot of people probably know, even if they don't know that they don't know that they know. It's a lot of no's right there. So we're going to talk about static electricity, and we're going to talk about current electricity. Now, a lot of you have probably heard of static electricity for sure. Now, static electricity basically is an imbalance of electrons, but it's electrons that aren't moving. It's electricity that isn't moving. That's why it's called static electricity. And a lot of times it's caused by this imbalance of electrons that aren't moving, and then you create this friction. You get that rubbing against something. That's why if you've ever been zapped by static electricity, if you rub your feet on the carpet and touch a doorknob or something, you get that zap. You're picking up those electrons that are sitting still and giving them somewhere to go. And that jump is what causes that zap. It's when those electrons are jumping. Compared to current electricity, which is basically electrons that are running. If you want to put it in terms of like a track and field, static electricity is the standing long jump. And current electricity is a 100-meter dash, right? It's that run compared to a jump. And we're going to do a couple demonstrations showing off each of those. Now, my first one, we are going to do some static electricity. Now, like I said, static electricity is when the electrons are sitting still, and it's caused by friction. It's that imbalance of electrons. So, what I've got right here in front of me, and I'll tilt the camera down when I start, but what I've got right here in front of me is a container with salt and pepper all mixed in together. And what I have right here is a balloon. Now, balloons are really, really good at picking up static electricity. They're really good at picking up electrons through friction. And what I have here is a beard. Now, the whole reason I grew this beard is so I could do this demonstration for you today. I promise there was absolutely no other reason. So what I'm going to do is I'm going to try to just pick up pepper out of this pepper and salt combination using static electricity. So what I'm going to do is I'm going to pick up the electrons that are sitting on my beard, and I'm going to transfer those over to my balloon through friction. Now, this is one of the best benefits of having a beard, because I'm going to pick up all those electrons. There's an imbalance of electrons right here, and what you're going to see is as I go over here, the pepper starts jumping off of the salt, and I pick up mostly pepper. Now, there's a little bit of salt that got on there that was kind of carried up by the pepper, but I could pick up a bunch of the pepper individually out of there. Now, this is a fun demonstration to do at home if you have a balloon and some salt and pepper, because that pepper's a lot lighter, so it's a lot easier to pick up the electrons and basically go to that charge. Now, those peppers have a neutral to positive charge. These electrons have a negative charge. So they're very attracted to this balloon. Now, because they're lighter, it takes a lot less of a indifference to really pull those up, which is why you can pull the peppers out so easy. But that's our static electricity. Let's talk about current electricity. Current electricity is the flow of electrons. It's those electrons running. It's typically what powers things like the lights or a lot of the electricity that you're used to seeing. It's much more efficient. But you need a closed circuit to get the current actually flowing, to get those electrons flowing all the way through. If that circuit is open, if that circuit is broken, the electrons won't flow through. And we've got a really cool thing here that we call energy sticks that helps show you what happens when you close the circuit. Now, I'm grabbing this end right here and nothing is happening. But the second I close this circuit, it lights up. It makes noise. It's that closed circuit right here. Now, what we have is conductive tape on each end, and then these little LEDs and noise maker things, basically electronics in here, that allow the electrons to flow all the way through. The electrons are flowing through my body into the conductive tape, which goes into here, through these wires, into the other end. When the circuit's broken, they can't go anywhere. The electrons don't make it all the way through. But there's other things that could also be conductive. And we're going to test a couple of these out. So what I have is two different sponges. They're the same type of sponge. They're the same sponge, but there's a key difference that I'm not going to tell you just yet. I've got some copper tape right here, some conductive copper tape. I've got a metal spoon, and I have a plastic spoon. And we're going to see which items are conductive. So let's try the metal spoon first. Holding on one end, got my metal spoon. So it looks like our metal spoon is conductive. Now, conductivity is essentially something's ease of electron flow. If something that is more conductive basically allows electrons to flow through it much easier. Something that is less conductive is typically called an insulator, which is something that does not allow electrons to flow through them very well. So now what I want to try is this sponge right here. I'm going to touch it to this sponge and close the circuit. Now nothing happens. Let's try the other sponge. So why is that happening? What do you think? I want to see somebody in the comments. Why do you think this sponge, same exact brand of sponge, same size, everything, why do we think this sponge and this sponge, what's the difference here? Why does this sponge allow an electron flow? Why is this sponge conductive? But why is this sponge not conductive? Anybody have a guess? I want to see somebody take a guess. Any guess is a good guess, but I want to see what you think. Why do we think this sponge is conductive and this one's not? And while you guys are typing that out, we're going to try our plastic spoon. Now let's see if our plastic spoon works. Nope. Nope. Doesn't look like our plastic spoon works. And then Mona says the top layer. That's a really, really good guess right here. So let's try it. Let's flip it over. Let's see if it's any different maybe on the bottom layer. So we still got some conductivity there. Let's try this one. Oh, so this one's got a little bit more conductivity. I like that guess. Now, why do we think that might be? What might the difference be? Top layer to bottom layer, because there might be a little something that's involved in this that is a super obvious thing that I don't think anybody's thinking about yet. Because what are sponges used for? What do they typically absorb? Any guess? I'm gonna go ahead and let you type that in. And then we're also gonna try to make a whole circuit. So I've got our conductive tape here. I'm gonna put this metal spoon on the top of our conductive tape. And then we're gonna see if we can make a circuit. Look at that. So you can start adding things in here. We'll put it on the sponge, resting on this. This is a very difficult situation here. But you can make a whole circuit there just by using conductive things. Now, Mona said the water. Absolutely right. So water is very, very conductive of electricity. And this sponge is much more wet than this sponge. However, this sponge might still have a little bit of water in there that is much easier to soak through on this side compared to this side. So if this sponge were completely dry, it wouldn't pass through. But with a little bit of water in there, that adds conductivity that allows the electrons to flow through. So that's a little bit of the difference between current electricity and static electricity. So go ahead and, I hope you could try some out. Try some of these static electricity experiments at home. Another really fun one to do with this balloon is to see if you can pull an empty soda can across the table, and you could have races. So I want you guys to go ahead and try that out at home. Thank you guys so much for joining. Always love bringing these Facebook Lives here to you. Go ahead and check us out at azscience.org to see all the awesome different things that we're offering, whether it's virtual content or in person. And come check us out at the Science Center now that we are reopened, and we'd love to see you all there. Make sure you're staying safe. Anytime you're out in public, go ahead and wear those masks, wash your hands, make sure we're not touching our face to keep yourself safe and keep everybody else around you safe. Again, my name is Maverick, and as always, thank you guys so much for joining me, and have an awesome rest of your day, guys. Bye, everyone.